come into my bedroom, come in at night. Y'all take your boy, I'm gonna skin it alive. Where, hold it now, love, y'all gonna get cut. Where, hold it down, love, didn't know for what.
right, so welcome back to spring semester here. This is CSCE 156. I'm Dr. Chris Burke, and I will be live streaming all the lectures. So I of course, check the audio when we start to make sure that everything is working. But otherwise, today we're going to give you a course introduction, and then we're going to immediately get started because we lost a day already. But today we're going to just start with the course itself. And the outline that I'm going to give you is that we're going to give a little bit of a course mantra or overview. We'll go through the basic schedule, talk about the project that you'll be doing this entire semester, and then discuss some resources and how best to go about approaching this course. So everybody in here would have taken a CS1 course last semester. Some of you might have taken it before or gotten credit somehow. But at the end of a CS1 Computer Science 1 course, you should be able to approach a reasonably complex problem and design a top-down solution that is taking the problem and breaking it up into smaller and smaller chunks until you've got one line of code or one function that you can use, and then program it, code up a solution in a high-level programming language. Some of you, that would be C. Some of you, that would be Python. Others might be Java, which we'll be using in this course. It might be MATLAB or something like that. It doesn't matter. A high-level programming language. The key realizations that you should have coming out of that kind of course are that computers don't solve problems, right? You're the problem solver still. Computers are dumb and they do exactly what they're told. Even the bleeding edge AI, they can only regurgitate what they've been trained on, what those models have been trained on. There are no ghosts in the machine, and programs only automate solution. Computers are really good at processing large amounts of data very, very quickly. Humans are not good at that, but humans are good at problem solving. Computers are not good at that. And so the mantra that I use in CS1 is a quote by Michael Crichton here. By the time that this might be Douglas Adams actually. By the time you've sorted out a complicated idea into little steps that even a stupid machine can deal with, you've certainly learned about something about it yourself, right? So that's problem solving. That you solve a problem by breaking it down so that it's so small of a problem that even a dumb machine can do something with it, right? We're going to flip that. In Computer Science 2, at the end of Computer Science 2, you should be able to approach a reasonably complex problem, the same thing, but ask design questions first. So instead of a top-down solution, you're going to go with a bottom-up solution. What entities or objects should I design first in order to model the problem? How are these objects going to interact with each other in order to solve another part of that problem? And what data structures can I just pull off the shelf so that it would be trivially solvable? For example, by the end, we'll have talked about a heap. And you can take this heap, and you can take a bunch of stuff and just throw it into this data structure. Then pull it out, and magically it's all sorted. That's called heap sort. Smart data structure, dumb code, just put stuff in, take stuff out. And that's the quote here from Eric S. Raymond: smart data structures and dumb code work a lot better than the other way around, right? So that's a fundamentally different way of approaching a problem, a bottom-up solution kind of, right? As far as our schedule goes, it's a 15-week, of course. So for the first 3 weeks, we're going to introduce you to Java, right? Because that's a second programming language for most of you. Again, a lot of you are coming from C, a lot of you are coming from Python. Doesn't matter. We're now going to do Java. You're going to learn at least 5 languages throughout your matriculation, maybe more. And in your daily lives, when you move on, you're probably going to only learn 2, or you're going to use 2 and 3 in your daily lives. Depends on where you work. But of course, you ever switch jobs, they might be a .NET house. Now you need to use C#. You need to learn as many languages as possible and understand that they're all the same, right? Just the way that they do things is a little bit different. Then we're going to get into object-oriented programming in the next 3 weeks in the context of Java. Then we'll move our attention to databases and database design, SQL, structured query language, and database connectivity. So you'll learn another programming language, SQL. Right? And then we'll go into data structures and algorithms in the last third of the course. List data structures, algorithms, algorithm analysis, searching and sorting, a quick review of that, stacks and queues, binary search trees, and heaps at the end. Right? The assessment for this course is based on 2 things. One of them are labs, and the other are assignments, right? So labs, there are 14 total, right? In other words, labs and assignments, there are no exams for this course, no quizzes or anything like that. It's all based purely on the design work that you do. The labs are about 20% of your grade, and there are 14 of them. Basically, starter code is provided via GitHub. Some of you have probably already taken the first lab and have seen this. Some of you might have walked through that first video that I gave of, it's a complete walkthrough of Lab 1 to get you started. Others will be doing that later today, right? Attendance is required, and it's 5 points, right? We'll talk about that here in a second. But otherwise, learning assistance, it's like a 1-to-9 ratio. So if you're in one of the larger lab sessions with like 40 people, there will be 4 learning assistants there helping everybody. If you're in one of the smaller ones in the morning or in the evening, there are only going to be 9 of you there, so there's going to be at least 1 learning assistant to help you out, right? But they can be completed asynchronously. So if you've already done Lab 1, and I checked, there were like maybe a half dozen folks that have already done Lab 1 and turned it in, you can go ahead and complete them before coming to Lab if you want to. But they are due on Wednesdays at midnight. Those are Cinderella due dates. So you have your lab session the same day, it's due at that midnight. So if you don't get it done during the lab, fine, just get it done by midnight. Right? No late work is accepted. We'll talk about that later on. But otherwise, it is based on the JUnit test cases. If you haven't seen it yet, you'll see it today. You write some code, we give you some starter code, you write some code to complete it, you hit a button, and it runs all of these JUnit test suites, right? It could be 5, it could be 100 different tests that we do. If you pass them all, you get your 20 points, 20 out of 20. If even one of them fails, you need to keep working on it until it's complete. They're based on completion. Right? So it could be a 0 out of 20. Right? The attendance points, we're going to mark those down. If you attend, we're going to mark you down as 5, regardless of whether or not you finish the lab. Right? Great, you attended. If you do not attend because you're sick, you decided not to, you slept in, whatever the reason, doesn't matter, you can always earn those 5 points back by getting a 20 out of 20 on the lab. Right? We'll run a script after lab is done on the next day on Thursdays is when I run it, and it will go in and award you those 20 points in Canvas, and it looks, oh, they attended, okay, great, there's their 5 points anyway. Oh, they didn't attend, that's 0, but oh, they got 20%, they got 20 out of 20 on the lab, so we'll go ahead and bump that back up to 5. Right? That's a differential attendance policy. I would highly advise you to come to lab, period. Right? But certainly within the first 3 weeks, just to get used to the labs and get used to the groove of everything. Right? Later on, if you decide I can do the labs on my own and prove it, right, by doing it and making sure that you get those 5 points whether you attend or not. Okay? The other 80% of your points are based on assignments, and they're exactly 8 assignments, plus a design document. Each assignment is worth a different amount of points, but they're roughly about the same. We start our assignment, the first assignment that's due is due about 3 weeks from now, assignment 0.0. Why did I number this 0.0? We're all computer scientists. Where do we start counting? 0, exactly. Right? So 3 basic programs in Java. Right? It's individual, no partners, no collaboration. The reason that we do that is because you need to prove that you're ready for this course, right? And these are all programs that are taken from CS1. In fact, if you took my 155E course, you'll immediately recognize them, right? They were all used in last semester here. And if you can do them in the language that you're familiar with, great, right? Then now you're going to do them in Java as you learn, right? If you could not do them in the language that you're familiar with, like you're familiar with Python, but I have no idea how to do this assignment, speak to an advisor immediately, right? Because you might not be ready for this course. Otherwise, the other assignments are 1 through 7, project phases. The first phase is where you'll be designing a bunch of objects and EDI, electronic data interchange. You'll be translating from CSV files, comma-separated value data files, into JSON or XML. All the details are in there. But that's 3 weeks from now. Then the next phase is going to be an application design and implementation. The next phase is a database design, database loading, database persistence, and finally, you're going to design an ADT, a list-based ADT, and integrate it. Right? All these details will be later on. This is just the basic outline. And then, of course, on each one of these assignments, you'll be maintaining what's called a design document. A design document is a living document. Right, that will be maintained and updated on each phase. It's due 1 week before each phase. There is no design document on the first assignment because the first assignment is just a bunch of small programs. But each phase, you'll have a design document due 1 week prior to the actual code. The draft is graded. We're going to look at it and say, yes, this looks like a nice draft for what you're doing so far. We'll give you your full points, but we'll also give you feedback on your design. So if you give us a sketch of all your classes and say, well, this class has these variables and these functions, great. We're going to critique it and say, no, that's wrong, right? You're going to lose a bunch of points if you do it this way, or you're going to have a hard time doing X, Y, Z if you do it like this. We're going to give you that kind of feedback so that you can actually incorporate that into your programs, right? But otherwise, if it's a bad design in the design document, that's fine. You still get all your points. It's completion, right? It's going to give you we do this for 2 reasons. One of the reasons is so that you can improve your design, so that you don't you're not just waiting to the last possible second, throwing something together and seeing if it works. That's not going to work, right? Instead, that you're going to have to take that feedback and incorporate it into your programs. The second reason that we do this is to give you exposure to technical writing. And in the third week, I'll have somebody from the Writing Center come in and help out with talking about how to do technical writing. It is not like writing a poem or creative writing or the 5-paragraph essay. You're not going to have to write a lot. In fact, you shouldn't write a lot. Technical writing, the key to technical writing is writing as least amount as possible, right? Taking diagrams and making sure that the diagrams are correct so that you don't have to write an entire four-page description of your design, right? We do give you an IEEE template. That's a Word file or LaTeX. If you're into LaTeX, we also have a template for that. But otherwise, more details on that will be provided later on. Okay. Collaboration is highly encouraged, except on that first assignment. In all of your labs, we'll in fact ask you, do you want to be paired up? And we'll randomly pair you up. If you want to work alone, that's perfectly fine. But otherwise, we'll try to facilitate working together in the labs. On all the assignments except for assignment 1, on all of this project, we encourage you to work in pairs, right? Even after you pair up, right, you're going to turn in one version of it and one version only, and that needs to be an equal amount of work, right? You're not just going to go, well, you do phase 1 and I'll do phase 2, and then we'll switch off, right? You're not going to learn anything that way. Why would you want to team up in pairs? Because it's easy to bounce ideas off of each other, right? It's the development of those soft skills, communication, teamwork, and unfortunately, maybe conflict resolution, right? So your partner is not pulling their weight. You're doing all the work. That's a partnership that needs to be dissolved, right? And conflict resolution. You need to approach your partner and be comfortable with approaching your partner and saying, look, you're not doing everything what I need you to do. We're not doing an equitable share here. I need you to pick up, and here's my expectations. Otherwise, in the next phase, we're going to have to dissolve this partnership, and I'm going to go my own way, right? We can help you facilitate that if you need to, right? But otherwise, it gives you this kind of practice of good communication, good teamwork, time management, and stuff like that, right? Be careful, because as I said, partners can mooch. They can flake out. They can disappear. Usually there's about a 15 to 20% drop rate in this course, right? Not as bad as like a Computer Science 1 course, but it's still a reality, right? Choosing to work in a pair means that you are taking responsibility for yourself and your partner at that point, right? Because if your partner was supposed to do something and they never did it and you were waiting on that, well, first of all, that shouldn't happen. You should be working equitably, but don't wait at the last minute, right? Dissolve that partnership and move on. Don't undermine the learning process of another person by facilitating that. For example, we'll go ahead and partner up, and I plan to do everything because I have to have control over everything. If you're that kind of personality, maybe you should work alone, right? But don't undermine the learning process of your partner. Don't undermine your own learning process. Also, use Git. We've got a video on how to use it with Eclipse. If you are going to pair up, then you need to pair up in Canvas. The instructions are in that first assignment, or that first phase of the assignments. Right? And I should say that the use of AI tools is prohibited for this course. All the design needs to be your own. Okay? Take the long view for this course. Get started now. And I'm going to show you a tool to get started immediately. Have a good, well thought out design on paper. That's your design document. That's the purpose of your design document before you even open up Eclipse to start coding. Design your test cases before you start coding so that you understand the problem a little bit better. Use proper debugging techniques. I'll show you, we'll demonstrate Eclipse, and I'll demonstrate eventually the debugger using Eclipse. Remember the mantra of this course, smart data structures and dumb code are a lot better than the other way around. Instead of just throwing a brute force solution at something, which probably will not work, start thinking in terms of what data structure would be perfect to make this so that I just have to write a few lines of code. Right? Also keep in mind technical debt. If you don't have time to do it right the first time, you're going to have to find time to do it over. As I said, these phases build on each other. If you have a bad design in phase 1, you're kind of screwed for phase 2. Right? So you need to do it right the first time, or in phase 2, you're going to be refactoring, debugging, rewriting that first phase anyway in order to get it to work with phase 2. Right? These build on each other, so don't fall behind. Right? Technical debt is where you do the opposite of that, where I'm just going to go ahead and do it really quick, throw something together. You have taken out a loan on your future self, a loan on your time. And guess what happens with loans? You pay interest on them. If you just spent 1 hour of design up front, that'll save you 5 hours of frustration later on. Right? So keep that in mind. Attend help hours early. We've got over 40 help hours a week or something like that. We've got like 16 learning assistants that hold their office hours or help hours throughout the week. We'll take a look at that in Canvas here in a second. Any questions before that, though? No? Okay. So the first, before we do that, I want to show you a tool that is available in Canvas. Let's see, where is it? I need to open it up locally. It's called a Gantt chart. So a Gantt chart is, I believe, well over 100 years old. The idea of a Gantt chart is, it's basically a way that you can manage, do project management. You have a certain due date. For example, for assignment 0 here, your due date is on Friday the 7th, it looks like, right? Then you need to work backwards. Well, I know that I'm going to have to read the handout at some point, right? I'm going to have to set up my Eclipse and outline my programs. I'm going to have to design my test cases. I'm going to have a first draft of the code. Maybe it's not working. Maybe it's not fully done or whatever, because I'm going to give myself a few days to debug, refactor, and rewrite things and clean things up. Then I'm going to submit and test with the grader, giving myself 2 days to do that because maybe there's a bug that was not in my code, that was not apparent in my code, but now the grader is showing that, well, no, you're failing this test case for some reason. Then you work backwards. It's going to take me 2 days to do that. Okay, fine. It's going to take me 3 days to do that. It's going to take me 2 days to do that. And you work all the way back until the first day, or the current day right now. For example, read and understand the handout. Once you've done that, you can go ahead and mark that down as 100% done. Right? Now I am on time, right? Before I was behind, right? Because here's today highlighted in red in this column, and here's where I should have started on it. Don't worry, it was Martin Luther King Day, and this one we didn't have class, right? So just by reading the handout, or at least skimming the handout, because I'm going to have to reread it later on, I'll go ahead and mark that down as 100%. Maybe it's not 100% though, because I know that I need to come back and reread it at some point. So I'm going to mark that down as 70%. Right? It will highlight that, oh yeah, you are on track, or you're behind, or you're ahead. For example, I already did lab 1, so I'm going to go ahead and mark that. Hey, now I'm ahead. Right? So this is available to everyone. You can go ahead and fill in your name here. It's not something that you're going to hand in. It's something that if you are not good at self-management, if you're not good at self-discipline, this is an excellent tool to do so, right? So let me go ahead and restore that to 0% there. Right? I've done the first 3 assignments here, assignment 0, 1, and 3, 2, and 2 there, but then the rest of them you're on your own, right? Because as you go along, you might think, okay, I don't need a full day to do that, right? I just need a half a day or something. Or this one, that's not 3 days. I only need to give myself, say, 2 days to do that. You can go ahead and update the dates on this, and it'll shift everything over automatically. Am I on track for the behavior that I've demonstrated up till now? Right. So undo that. Right. You have this is available in Canvas. Okay. So let's go ahead and take a look at Canvas. Canvas. There you go. I do this course at UNO, and then there's another section right immediately after this. So generally, I won't be available for questions immediately after. I've got to get over there and get set up. But otherwise, let's go ahead and take a look at this one. Everything is already published. It's all available. You can get help here, getting help. More information about the LA program. There's a course FAQ, frequently asked questions. There's more course info here and other resources. But otherwise, here is the main landing page of Canvas. You'll see here that on, that we didn't have Monday, so I need to erase that. But on Wednesday here, after we're done, I will update this link to a recording of the live stream here. It is recommended that you read the syllabus. It's pretty much, it contains more details, but pretty much we've covered everything already. And there's that Gantt chart. The first 3 videos are getting started. So I think the first video is a walkthrough through Lab 1. The second video is a introduction to Git using Eclipse. And then the third one is how to set up your project for when you start the phases 1 through 7. All right? We might link back to it eventually. But otherwise, each week you have a lab. You also may have required reading or required watching. For example, I have 13 videos here on a quick introduction to Java. This is what we're going to be doing for the next 3 weeks. But I also have 13 other pre-prepared videos, short 5, 10, 20-minute videos, going through various, this is all on YouTube, by the way, going through various elements of Java. Let's see. There we go. Quick intro to Java, basics and getting started, which is where we'll start today. Variables, operators, output, all the way down to some exercises that we've done in the past, like string entropy, password cracking, and ranked voting here. Okay, so I have videos on most modules. Unfortunately, I don't have them when we get to object-oriented programming, nor do I have a textbook chapter on that. But later on in other material, I do have a chapter on a free textbook here on an introduction to databases and SQL. I also have an 8 video series on that. Okay. So every week you'll have the lecture material, you'll have your lab material, you'll have required reading and or watching, and then the assignments that are due. What's due today is your lab 1, but what's due this Friday is this pre-course survey. So make sure that you're filling that out by Friday. It's just completion. Once you've filled it out, you get the full points for it. I think it's like 15 or 20 points or something like that. Okay. So make sure that you're doing that pre-course survey by Friday midnight. All the due dates here are going to be Cinderella due dates. Cinderella due dates, the midnight, she turns back into a pumpkin. That's why we call it that. Hopefully you're okay with dark mode. I forget how to get back out to light mode. But otherwise, here's the full syllabus. There's the description of the course. The learning objectives and outcomes. Again, you should be able to easily pick up a new programming language after having 2 under your belt. You should be able to recognize, use, and design things with an OOP, object-oriented programming flavor. You should be able to design a database back system and from scratch, given a general statement. And then you should be able to understand and implement basic data structures. And then basic algorithms as well. Okay. There's the full assessment, starter points. That's just to make everything round up to an even number there. There's the surveys with 15 points apparently for the first one. At the end of the course, there will be another survey. That's 15 points. 14 labs, 25 points each, 5 points attendance, 20 points on the lab itself. And then there are 8 assignments plus the design document. Again, that's about 80% of your grade. There's a standard letter grade scale there. More information on the labs that I've already covered. Again, lab attendance is required unless you earn your full 20 points, in which case we'll give you the attendance points. No late work on the assignments. The 15-week policy, your last assignment, and the design document, I believe, are due, let's check it out, are due on that Friday of Dead Week. Right? There's Dead Week, and there's your design document and assignment 1 and the post-course survey. So as per the 15-week policy, you've been notified that you will have stuff due during Dead Week. What is noticeably absent here? Finals week. What did I say? No final, no exams, no quizzes. All right? So once you're done with those elements in Dead Week, you're done with the course. Okay? Back over here to the syllabus. We'll talk about grading later on, but everything has a rubric. Everything tells you exactly what points and exactly what we're expecting on everything. For example, let's look at the first assignment. Let's see, where's the first? Here's the assignments. This is linked to in Canvas. You don't need to go directly to GitHub here. But here's assignment 0. There are some files that go with it, some starter files there. But otherwise, here's assignment 0. There's an overview of what you should name your files. There's the first exercise. You have to read in 3 points. And then you have to tell me the distance between each of those each of those pairs, and then tell me what the 2 closest points are, right? Using this formula up here. Easy. That's a basic input-output program. In fact, by the end of make it a personal goal that by the end of the week you should have this program done. That would mean that you're slightly ahead. Here's another exercise where you're doing arrays and testing. Right? We introduce you to JUnit, and you have to convert, say, I think this is a map, a 3x5 grid of in feet, and then you have to convert that to meters or vice versa or whatever it is. Right? We tell you about how to set your program up for unit testing and for JUnit. And then we give you a bunch of running app data where you have to produce several reports. You have to produce an elevation report, elevation gain report, report on data anomalies, etc. But here's the rubric that I was talking about. We expect everything to have good style. That is, good variable names, good function names, method names. You should have good use of white space. It shouldn't be all over the place. You should have clean, readable code. You should have well-written comments. Right? At this point, we're expecting author documentation mostly. Right? It should explain the what and the why, and it shouldn't be overly verbose. You should, and I'll demonstrate this when we get to Java here in a second. But they should be your code should be self-documenting. Right? You shouldn't. Any comments that you put in there should explain the why. Right? The why and the what, not the how. The code is what tells me how. Okay. Then we also have program design. It's well written and efficient. It's easily understood and maintainable, et cetera, et cetera. But the bulk of stuff is going to be based on correctness. Every program, every phase is going to have a rubric that looks something like this. Point values, maybe specific point values that if you do this, we're taking off 10 points. If you do that, we're taking off 5 points. Right? But something like this. So be cognizant of that rubric and the grading. No late work is accepted. It has to work in the WebGrader. If it doesn't work in the WebGrader, we can't grade it. You're out of luck. Right? Academic integrity, standard policy. All homework it has to be your own unless otherwise stated. Labs are perfectly fine to collaborate. Assignments 1 through 7 are perfectly fine to work in pairs. Not 3s, not 4s. That's way too much of a diffusion of responsibility. If you are interested in the honors section, please let me know, and we can talk about it. But there are higher expectations there. For example, in most of the assignments, we have bonus, not this one, but in other assignments, we have bonus points. Those become required in the honors section. Best way to communicate is through CampusWire here. You should all have received an invitation. Make sure that you're accepting it. Right? I've already posted a welcome message on what you can and should be doing. Each week I post what we're doing this week. Right? For example, on Wednesday, right, we'll give a brief course introduction, which is exactly what we're doing right now. Also on Wednesday is your first lab is due. And finally, you have a pre-course survey that's due by Friday. Right? That will be updated on a weekly basis. And in fact, we'll have sticky posts here or pinned posts here for each assignment as well. I just haven't made it for assignment 0 yet. Okay. Otherwise, there's the syllabus. Go ahead and read it at your leisure. All right. What else? Any questions? No? Okay. Well, let's just go ahead and get into it then, right? Since you're going to be doing this in your lab anyway. An introduction to Java. Right? Java is an object-oriented programming language that is now, it's 2025, right? So 1995, I think it was. So it's its 30th anniversary, I think, right? It was created 30 years ago, and it was designed to be a write once, compile once, run anywhere language. Whereas with C, right, you have a compiler, and it's compiled for that machine only. If I compile it for my Mac, it can only ever run on the Mac, right? And in fact, I need a special compiler for my Mac. I would need a special different compiler for Windows. It would only run on that machine. With Java, however, you have what's called a Java virtual machine, where you compile it once with the Java compiler, and any system that has a Java virtual machine, it can run. And in fact, it's backwards compatible, right? Java is a class-based object-oriented programming language, which means that everything in Java is a class or belongs to a class. Unlike Python, where you can just start writing whatever the hell you want, anywhere you want, right? Nope, you have to have a class and you have to have organization and structure. With C, you don't even have classes. So let's take a look at what it looks like. Here is Eclipse, right? Once you've run through the instructions to download Java and download and install Eclipse, by the way, you can use whatever you want. There's IntelliJ, there's BlueJ, there's VS Code, right? Whatever IDE and integrated development environment you want to use, that's your business, but all the instructions will be tailored to Eclipse. So if you want to go ahead and try IntelliJ, that's fine. You're just going to have to figure out how to translate everything, all the instructions in Eclipse over to IntelliJ. I do have some resources, though, on that, so for IntelliJ only, not VS Code. But we would recommend that you go with Eclipse here because it's free, right? IntelliJ is free for you, but I believe that the actual license is like $100 a month, right? So it's free for students in order to get students hooked on it so that when you become professionals, you're paying thousands of dollars a year for it or getting your employer to do so. But otherwise, Eclipse is free and always will be free. Let me go ahead and create a new Java project here. Right? And I'm going to tailor it to this course, so I'm going to call it CSCE 156. Right? You may or may not have this little checkbox here enabled. Let me move that over so it appears in the live stream. Right? Probably by default, this will be enabled. Make sure you disable it. Right? You're going to have a problem with modules if you enable that. Right? The full instructions are in Lab 1. Okay? So don't worry about following this exactly. And it's in that video. Okay? There is my new project. Right? There's nothing in the SRC file, or SRC folder, excuse me. SRC is short for, guess what? Source. So let me put something in there. A package. Right? And I'll call it unl.soc. UNL, University of Nebraska-Lincoln, SOC, School of Computing. Right? That's not code. Let me show you what that actually is by going to Properties, and I'm going to open this up on my computer. Okay? There is our project folder, CSCE 156. In that, you've got two things. You've got a bin folder, and you've got a source folder. I didn't see a bin folder over here, did you? No. Nope. I did see a SRC folder, though, which has a UNL folder and an SOC directory. What does that tell you about packages? They're directories. It's a way to organize code. You can put math stuff in the math directory. You can put business CSV stuff in the CSV directory or whatever. It's a way to organize code. What the hell is this bin over here? It has the same UNL SOC. Let's find out by creating a class first. I'm going to go ahead and create a new class, and I'm going to call this Hello World. Did I spell it right? Yep, there we go. Right. So why do we always do Hello World as the very first program in any programming language? To make sure the compiler works, to make sure that it's runnable, right? Otherwise, you're stuck, right? You can't do anything. I'm going to go ahead and create a public static void main, string args. There we go. Those of you coming from a C background, does the main look familiar? Right? That's the starting point of any program. Void, that should look familiar. What's the return value on this? Nothing. It returns nothing. And args, we've got arguments here. I forgot that there. Even in Python, you would do something like this. In Python, you could you have to like underscore main, right? Something like this. Maybe you didn't do it in Python, but underscore def underscore main, something like this. That's how you would define a main in Python. Or you could just go ahead and start disorganizedly writing whatever the hell you want, wherever the hell you want. Not a great idea in Python. But you still have a main in Python. All right. Now let's go ahead and go with system.out.println hello world. This should look familiar to a lot of folks, right? Print ln. Well, that's not too familiar because in C, what I would do is say printf hello world. It looks very, very similar though, right? Printf, println, what do you think the difference is? That ln, line. In other words, I don't have to insert my own line manually here. It will insert one for me. If you're coming from a Python background, what would you do? Print, hello world, And by default, your print function here automatically inserts that n line character, that special character. That's a special character. It's a \n, because if I just typed it like that, you can't just type an n-line character and get it to print an n-line character. I have to explicitly type the n-line character. But here, it's taken care of for me. Okay? Actually, it would be far better to do what in Python? No semicolons, even though it's allowed, and then you would do an f string instead. Right? That's way better in Python. Right? But there we go. Right? There's my hello world program. So how do I get this running? There's a nice little play button up here. When I play it, the output is output down here to the console. So if you're familiar with VS Code and the code spaces, if you used it last semester, then it's exactly the same setup. Files over here, your editor over here, your console down here. You probably had something like if you used, what is it, PyCharm? Did you use what did you use in 155A? PyCharm? Nothing? Okay, we don't remember. We don't have any 155A folks here? Okay, I'll find out then somewhere. All right. I'll ask them. Anyway, there are two things though that still can make this better. One is documentation. This is a special kind of documentation that's a Java doc. Right? I'm going to, at a minimum, we are expecting that you have an authorship documentation. So here I am. There's me. My email, if I want to, it doesn't really matter, but there's how you can contact me. And then the date, 2025. Today is the 22nd, it looks like, in the standard best ISO 8601 standard right there. And then finally, the purpose of the program. Prints hello world to the standard output. That's all the documentation we're looking at right now. We're looking for. What would be bad documentation? Bad documentation would be something like this. Prints hello world to the standard output. First of all, I've violated the DRY principle. Do not repeat yourself, or don't repeat yourself. I've repeated it here and I've repeated it here. Not only that, but now that I've explained what this line of code does, system, the standard system, output, print, and then you told me ln line, and then I've got a string right here. Do you understand what that line does? Yeah. Do you need to read this English in order to understand what that line does? No. It should not be there. This is what we call cruft. Cruft, right? It's garbage that should be taken out and dealt with, right? The word comes from either Harvard or Yale or whatever. The story goes that there's this Cruft Hall. It was just one of their buildings that became disused and nobody was using it. So you had a broken overhead projector or you had some broken equipment. What do? We'll take it over to Cruft Hall and store it because somebody might want to fix it, somebody might want to use it, right? And eventually the entire building filled up with garbage. Right? And that's where the term cruft comes up in. This is garbage. It should not be there in your final program, right? Get rid of it, okay? There is a perfect hello world program. Good documentation, good indentation, good white space. What would it look like if it's bad white space, right? Something like that, and then I begin my opening bracket over here, and then I disrespect that indentation there. I disrespect that, right? That is definitely points off because it is not at all readable, right? Don't worry, you can fix it with one keystroke. Shift, Command, and this is a Mac, by the way, so Shift, Command, F, and it all goes back to nice. Now, unfortunately, it does get kind of aggressive on your comments, so you might want to come back and fix that. And also, I don't know why it didn't do that, but that's the proper way of doing it, right? There, and then I'll undo. I like that better, right? But just be consistent about it. You can, if you just start typing, of course, it'll do it for you. Proper indentation right here, just like any IDE. For those coming from a Python background, the indentation doesn't matter as far as white space goes, but it does matter as far as your style points go. For example, in Python, if you did something like this, it's a completely different program. Whether or not it runs, I have no idea. Right? But indentation matters for style, not for correctness. Okay? All right, let's come back over here and discuss what we've just done. Let's see. Where's my... Where are you? Okay, there I am. All right. So again, classes are simply units that are declared in their own source files. Right? My hello world file is actually a hello world.java file. Over here, if I go back to that source file, see UNL SOC, there's that hello world.java file. Right? If I come back over here and go to that bin folder, what do you think bin stands for? What do you think that's short for? Binary. It's already been compiled by Eclipse. UNL SOC hello world.class. Now, if I were to open that up in Eclipse, let me try by dragging and dropping it over here. Right? It's not really human readable. Right? There's some bytecode here that you can't see, that it's not rendering. Some of it is like this mysterious stuff, right? It's kind of human readable. Hello world, that's certainly something that's readable. But otherwise, for the most part, this is not something that you would generally read. This is Java bytecode. It is intended for the Java virtual machine to interpret and execute. It is a compiled language. It's half compiled. It's compiled into Java bytecode. But otherwise, you don't have to worry about that, right? What you do have to worry about is correct naming, right? What if I had called this hello world instead with a lowercase h? Does that match the name of the file? Nope. Case sensitive, right? What if I misspelled it in other ways? Hello world, right? That's also a compiler error. What happens with a compiler error? It highlights it in red, and it gives you some options, right? It tells you what's wrong if you hover over here, but if you hover over here, it gives you some options. Do you want to rename the entire file to whole world, or do you want to rename this to the proper spelling of hello world? Make sure that you're choosing the right one. If you choose the wrong one, right, what I've just done is I've renamed the entire file over here to whole world, right? That's not right. So let me restore that, right? And then, come on. Okay, I just did undo, right? Undo, and put it back to hello world, okay? If I misspell this, it gives me the correct option here of rename it to back to hello world. Make sure that you're spelling it correctly, okay? So they must have the same file names as your classes. Source files are compiled to Java.class files that then run on the JVM, which is the Java virtual machine. Right? IDEs like Eclipse hide all of these details. You could do this from the command line. Javac, Javac is the Java compiler. You could compile it, and then you could invoke the Java virtual machine by using Java, and then have class paths and a whole bunch of complicated stuff that gets boiled down to one button click here, right? That's why we like to use IDEs, because all those details are hidden away from us. It's compiling in the background every keystroke or every second. I can run it simply by pushing a button. Right? IDEs all make those details opaque to us. Right? As we already saw, the classes are organized into packages, which are nothing more than folders or directories. Right? And packages are your way of organizing things into folders and subfolders. Right? Let me go ahead and copy and paste that hello world example. Right? So I'm doing this to demonstrate how the notes for this course are going to work out. Right? I'm going to go ahead and cut and paste this, and eventually this will be posted to GitHub. Right? I'll put out the link later on when we have our weekly update. But otherwise, if you go to GitHub for this course, again, I'm teaching 3 versions of this. So if you go to Notes, make sure that you're going to the correct semester, Spring 25. Make sure that you're going to the correct course. There we go. And there's some intro notes that have already been posted. These notes have not been posted, but when they do, they'll look something like this. Nice code highlighting, color-coded syntax highlighting, and stuff like that. So everything will be available in the repository here. There's our Hello World program. Right? And you should follow the same convention that I just did. Right? Class name should follow an upper camel casing convention. If you're coming from a Python background, how did you do everything in Python? Python. Variables are lower underscore case, right? Or snake case. Right? That's not in Java. In Java, the classes are upper camel casing, so all of them are shoved together, no underscores. The first letter is uppercase, and all the other subsequent letters in each word are lowercase. The first letter of each word is uppercase. Variables in Java are lower camel case. We call it lower and upper because of the first one. We call it camel casing because if you look at it as a bunch of camels walking along, they've all got their humps, right? So it looks like there's a bunch of humped camels there, right? Okay. Everything is everything is case sensitive. Right? I believe the same as can be said of well, certainly C, but Python as well. Right? Comments, as we've already seen, this is different from Python, but it's the same as C. You have multi-line, which are going to be you begin with a slash star and then end with a star slash. Right? You have single line. Right? How did you do it in Python, by the way? What is the single line comment in Python? Hash. Hopefully we remember that, right? Are there no Python folks in here? Hopefully there are. Right? But in C, it's going to be, and in C and in Java, it's going to be slash slash. Is that a backslash or is that a forward slash? Forward slash, because if you look that way, you are leaning forward or you are leaning backwards. Right? And then finally, special doc style comments, right? Which are slash star star plus a vertical line of stars plus the ending, where it's going to be star slash. Right? That's what it looks like in our Hello World program up here, this documentation. Slash star star, vertical line of stars, and then finally the last one is going to be star slash. If you just type in, let me go ahead and preserve this, but if you just type in slash star star and hit enter, it automatically does it for you. And then if you just start typing enter, it automatically puts in the stars there for you as well. Right? So a lot of IDE tricks here. Right? But otherwise, those are doc style comments. And as I said, avoid cruft. Your code should be self-documenting. For now, we expect author documentation for every class and documentation for non-trivial methods. More later. Right. Okay. 2 minutes left. Any questions? No? Then you'll be going through exactly what we did and more in today's lab. And remember that it's due this tonight by midnight. Okay.